Matt wants to withdraw $500 at the end of each month for 9 months. His account earns 5.4% per year, compounded monthly. How much money is needed to cover his withdrawals? I will equal 5.4% divided by 12, which will equal 0.0045. N will equal 9. R will equal 500. To PV, which is present value, will equal R bracket 1 minus bracket 1 plus I bracket exponent power negative n bracket divided by I, which will equal 500 bracket 1 subtract bracket 1 plus 0.0045 bracket to the power of negative 9 bracket divided by 0.0045, which will equal 500 bracket 1 subtract bracket 1.0045 bracket to the power of negative 9 bracket divided by 0.0045. This will equal 500 bracket 1 subtract bracket 0.96039 bracket to the power of over 0.0045. This will equal 19.8017925 divided by 0.0045, which will equal 4,400 decimal 3983333. Therefore, Matt needs $4,400.39 in his account. If Matt deposited $750 at the end of each quarter for 3.5 years in an investment account that earns 15% per year compounded quarterly, how much will Matt have at the end of 3.5 years?
R will equal 750. I is 15 divided by 4, which equals 3.75%, which would be 0.0375. N equals 3.5 times 4, which ends up being 12. We have to use the formula, which is A equals R bracket 1 plus I bracket to the power of n take away 1 bracket all divided by 1, which is 750 bracket 1 plus 0.0375 bracket to the exponent of 12 minus 1 bracket divided by 0.0375. And then it would be 750 bracket 1.0375 bracket to the exponent of 12 take away 1 bracket divided by 0.0375. And then 750 bracket 1.55 take away 1 bracket divided by 0.0375. And then 750 bracket 0.555 bracket divided by 0.0375, which equals 416.59 divided by 0.0375, which equals 11,109.08, and that's how much you would have at the end.
If I wanted $1 million by the time I retired at the age of 53 and I started work today, what would I have to deposit monthly if I had an interest rate of 10%? I will equal 0.008, N will equal 432, A will equal 1 million. We'll use these numbers for the formula A equals R bracket 1 plus I bracket to the power of N subtract 1 bracket divided by I. After subbing all the numbers in and closing in the brackets, we're left with 1 million equals R bracket 30.2572 bracket divided by 0.008. We'll then times the 0.008 out of the division to the other side, so it'll be 1 million times 0.008 to give us 8,000 equals R bracket 30.2572. And then from there, to get R alone, we have to divide the 30.2572 by 8,000. R will equal 264.4. Therefore, I would have to deposit 264.4 every month until I retire if I want to have $1 million. Matt, he wants to buy a yacht for $100,000. He started an investment account that gains 15% bi-monthly. How much would he have to deposit bi-monthly to buy his boat in 5 years?
I equals 15 divided by 24 equals 0.625, which we would divide by 100 equals 0.00625. N equals 120. We use the formula which is A equals R bracket 1 plus I bracket to the exponent of N take away 1 bracket all divided by 1, which would be 100,000 equals R bracket 1 plus 0.00625 bracket to the exponent of 120 take away 1 bracket all divided by 0.00625. The first step we would do is the inside bracket, which we would get the answer 1.00625. Then we would use the exponent of 120 and get 2.112. We'd still stay in the brackets and subtract 1 to get 1.1120. Then we'd use 100,000 times 0.00625 equals R bracket 1.1120 bracket, which is 625 equals R bracket 1.1120. We divide 1.1120 by 625, which would equal R. Therefore, Matt has to deposit $562.05 bi-monthly to have $100,000 in the bank to buy his yacht in 5 years. The job we chose is a mathematician. Mathematicians are divided into two broad and overlapping categories: theoretical and applied. Theoretical mathematicians develop new principles as well as relationships between existing math principles. They are usually graduate students and professors working in research in academic settings. Applied mathematicians use mathematical principles, theories, and techniques to solve practical problems. They work in many areas, including business, industry, government, and healthcare. Theoretical math provides the basis for applied math. The core tasks of these people are theoretical mathematicians develop new math principles, those who work at universities have teaching duties, applied mathematicians solve practical problems using math. They work in many fields, including medicine, economics, and business. They work for the governments, companies, and universities. Most work a regular 40 hours a week, but professors work the longer hours. Theoretical mathematicians usually work by themselves. Applied mathematicians often work with other professionals. They earn anywhere between $40,000 a year to $140,000 a year, but the professors get paid more. Salaries do depend on the nature of the work. Mathematicians with PhDs earn the highest salaries. They all need to go to university and have at least a bachelor's degree in mathematics. A master's degree is needed for more advanced positions, and a PhD is required to teach at a university.